Good day, our esteemed viewers. Compliments of the season. Trigonometry is one of the many interesting topics of mathematics in our secondary schools. Oftentimes, in the external examinations conducted by the West Africa Examination Council, that is WAEC, and the National Examination Council, NECO, learners are usually required to solve problems on this topic without the use of calculator. In our classroom today, we shall channel our focus on how to obtain the values of some of these trig functions, making reference with angles 30 degrees, 45 degrees, and 60 degrees. The table on the board gives the values of some of these functions, alright, the special angles. How these values came to be is our concern for this lesson. Okay, so we're going to obtain the values and then we'll fill the answers up here and then compare the tables and see if what we did is correct. Alright, to obtain these values, we're going to be making use of three important tools. First, we're going to be making use of this acronym on the board, SOHCAHTOA. SOHCAHTOA is an acronym that gives the formula of obtaining these ratios. The S here stands for the sine functions, in short SIN. The C stands for the cosine function, and the T stands for the what? Tan function, in short TAN. This is the first tool we're going to be using. Secondly, we're going to be making use of the properties of the equilateral triangle and an isosceles triangle. Okay? Before now, we know that an equilateral triangle has all its sides to be equal and all its angles to be equal. Now let us consider an equilateral triangle of sides 2 units. Like this, 2, 2, 2. And of course, each of the angle will be what? 60 degrees, 60 degrees, 60 degrees. Because when you sum the angles up, it's going to give you what? It's going to give you 180 degrees. Alright? So, since each angle are equal, it has to be what? 60 degrees. Then I bisect one of the angle. Let me bisect this angle. This bisector will now divide this side equally. Okay, so bisecting angle divides this equilateral triangle into 2 right angles. Okay, so I'm going to bring out one right angle triangle. I bring it out. Of course, this will be what? 90 degrees. Bisector is perpendicular to the side. Okay, this side remains 60 degrees. This angle will become what? The bisector divides the angle into 230. So here will be what? 30 degrees. Of course, here will be what? 1. And here it remains what? 2. Here is 1 because the bisector divides this side into 2 equal parts. Since the whole side is 2, half of it will be 1. That's what you have here. And this side is what? Unknown. Now we have the right angle triangle. Okay? Now, when you make reference to any of the angle, let's say 30 degrees, the side facing the angle is referred to as what? Opposite sides, which is your O here, OPP, opposite. Okay? The longest side, or the side facing the right angle, is the hypotenuse, which is our HYP. Okay? And of course, the other side becomes what? The adjacent, which is what? A. Alright? Now, to obtain this unknown sides of this right angle triangle, we are going to be making use of the third tool, which is the what? The Pythagoras rule. Now, by Pythagoras, it says that the square of the longest sides of a right angle triangle is equal to the sum of the squares of the other 2 sides. Meaning that 2 square, which is the longest side, if you square it, the result will be the same as what? The sum of the squares of x and what? 1 square. This is the rule. When we rearrange, you're going to have that x square equals what? 2 square plus, minus 1 square. Alright? Which is what? X squared equals 4 minus 1, which gives us what? 3. Therefore, our x equals what now? Square root of what? 3. Which means this side x is what? Root 3. Now all the sides are complete. How do we now get the values of the ratios? Now for sine, this is the formula like I said. S here is given by what? Opposite over hypotenuse. Sine opposite over hypotenuse. Sine of an angle, let's start with 30 degrees. Sine 30 degrees is given by what? Opposite over what? Hypotenuse. The side facing this 30 degrees is 1, so the opposite is 1. You have 1 over hypotenuse is 2. We have 2. So sine 30 degrees is what? 1 over 2. Okay, we go to cos. Cos 30 degrees. Cos represented with what? C is given by what? Adjacent over what? Hypotenuse. We are still on this 30 degrees. The adjacent side is what? Root 3 over hypotenuse, which is what? Still 2. Okay, and then we have the tangent, the tan of 30 degrees. Tan is given by what? The opposite side over the what? Adjacent side. The opposite side of 30 is 1. The adjacent side of 30 is what? Root 3. So 30 degrees is what? 1 over root 3. That is it for 30 degrees. Now let's go to 60 degrees. For 60 degrees, sine of 60 degrees. Sine is given by what? Opposite over what? The hypotenuse. This is 60 degrees. The side facing the angle becomes opposite. No longer 1 again, right? This is the side facing angle. So this is opposite side of 60. So we have opposite over what? Hypotenuse. Opposite is what? Root 3. Hypotenuse is what? 2. So sine 60 is what? Root 3 over 2. Then we'll go to what? Cos 60 degrees. Cos is adjacent over hypotenuse. The adjacent side of 60 is what? 1. And the hypotenuse is what? 2. Alright? Then tan 60 degrees. Tan is given by the opposite side over the adjacent side. The opposite side is root 3. Adjacent side is what? 1. So we have root 3. Alright? Now going back to the other part of the board, we're going to have that what? Our sine 30 is what? 1 over 2. Is that correct? Yes, sine 30 is correct. 1 over 2. Our cos 30 is root 3 over 2. Our cos is correct. We have root 3 over 2. Our tan 30 is 1 over root 3. Tan 30 is 1 over root 3. Our sine 60 is root 3 over 2. Sine 60 root 3 over 2 here. Our cos 60 is 1 over 2. Is that correct? Yes, 1 over 2. And our tan 60 is what? Root 3. Correct. Root 3. That is that for what? 30 degrees and what? 60 degrees. Now we'll go to 45 degrees. For 45 degrees, we are going to make use of what? The isosceles triangle. And for isosceles triangle, one of the properties we know about it is what? 2 of its sides are equal. Alright? 2 of its sides are equal. Let us consider this 1, 1. Then we have this, right? Here to be what? 45 degrees. And here is not given, so we'll make it what? Y. Still, we're still going to make use of the Pythagoras rule to obtain the value of this missing side. Using Pythagoras, we can say that what? Y square, which is the longest sides, right? This is our 90 degrees. The longest side, which is y square, is equals to the what? The sum of the squares of the other two sides, which is what? 1 square plus 1 square. And of course, we know that y square will be what? 1 plus 1, which is what? 2. So our y will be equals to what now? Root 2. So y is what? Root 2. Now how do we get the ratios, the values of the ratios? Trig ratios. So tan 45 degrees now. Sorry, let's start with sine. Sine 45 degrees. Sine from Sukatwa is opposite over hypotenuse. It's given by opposite. The opposite side of this angle is what? 1 over hypotenuse. Hypotenuse is what? Root 2. 1 over root 2. Okay? Cos 45 degrees. Cos is given by adjacent over hypotenuse. Adjacent side is 1. Hypotenuse is root 2. 1 over root 2. And the tangent, the tan of 45 degrees, is given by what? The opposite side over the adjacent side, which is what? 1. So let's compare now with the table. Sin 45. Sin of 45 is 1 over root 2, correct? 1 over root 2. The cos of 45 cos of the same 1 over 2, correct? And the tan of 45 is what? The tan of 45 is what? 1. So you can see, making use of these 3 tools, we have derived the trig, the value of the trig ratios of 30 degrees, 45 degrees, and 60 degrees. Of course, in the exam hall, we may not have the ample time to do all this before we can use it to solve. There is short method, the hand tool. We can also use our fingers to derive the values of those ratios. And this we are going to be showing you in our next videos. Please do well to subscribe to our YouTube channel. Encourage us so that we'll serve you better. Thank you for listening. God bless you.